Have you ever wondered how you might be able to recreate some of the classic battle scene transitions from the Pokemon game series, and how you might be able to do this in the Phaser 3 framework? By utilizing WebGL and the built-in shader support of Phaser 3, we can create some really cool effects by creating some custom fragment shaders. With just a little bit of code, we can easily recreate many of the classic battle scene transitions from Pokemon. Some of these include a screen wipe from left to right, or from top to bottom. We can have curtains opening and closing. We can have vertical bars close towards the center of our screen or even open from the center of the screen. And we can even have basic fade in effects like fading in to white or fading out to black. If you are interested in learning how to create these types of shaders in Phaser 3, then stick around. So before we begin, if you'd like to follow along with the code, there will be a link in the description of this video to the direct download of the starting source code. And inside those project files, the README will have instructions on how to set up and run the code. If you'd like to follow along, please go ahead and download that code now and open it in your IDE of choice. For this video, I am using Phaser 3 version 3.80. Some of the features in this video might not be available in earlier versions, so if you're using this video as a reference, please keep that in mind. Also, in this video, I won't be going over the basics of shaders, but if you are interested in learning more, I do have a video that goes over that topic. There will be a card in the top right corner if you'd like to check out that video, and there will also be a link in the description of this video to that video. So let's get started. So before I jump into the code, I want to quickly go over the starting code template. And so the starting code template is just a basic Phaser 3 project that's set up for TypeScript. So inside the project files, we'll have our index.html, which will be our main web page for our game. And this is going to point to our source folder in our main.ts file. And so this is the main entry point for our web app where we create our Phaser 3 game configuration and we start our game. Under our scenes folder, this has our only scene that we'll be using. And so this scene has a bunch of boilerplate. And basically what we're doing is we're just adding a background image so we can see something in our scene. And then we're creating a bunch of custom pipelines that we're adding. And these pipelines are just basic boilerplate. So under our shaders, this is where all those pipelines live, and we'll come back to that. And for each of those shaders, we're tying them to TweakPane. And then that way we can use that GUI to go ahead and easily test each of our shaders as we build them. And so that's what the rest of our logic here is doing, is it's just connecting TweakPane to each shader and then allowing us to modify values on it. So then that way we can see what that pipeline does when we run it. So under our shaders folder, the main file is going to be this custom pipeline.ts file. And this is just an abstract class that extends our Phaser postfx pipeline. And basically all we're doing here is we're just adding in a custom variable that's going to be available inside the shaders that we build. From there, each of our other shaders will just extend that pipeline. And all we're doing right now is we're just rendering out the texture that's passed to our shader. So we're not doing anything custom with them right now. We're just going ahead and render out what's already there. So if you go ahead and start the project, what you should see this is in your web browser. And you'll see here with TweakPane, we now have access to all those shaders and we can see the variable properties. And so right now, when we hit the play button or if we modify the progress, nothing happens. And so that's because all of our shaders, like I said, we're just passing in this texture to our camera and then we're just rendering it out. And what we're going to do now is we'll add in our code to actually create the various effects that we want with our shader. So Phaser 3 has a number of built-in methods for utilizing WebGL and creating shaders in your game. A few of these are going to be pipelines that you can add to your game objects either before or after they render. And that's like what this postfx pipeline here does. And there's a number of other different type of pipelines that you can take a look at. For this video, we're going to focus on our postfx pipeline. And what that does is this allows you to apply special effects to your game objects after they've been rendered to your scene. And what's really cool about this pipeline is we can add it to our camera, and then we can apply our effect to the whole scene in our game. And with that, that's how we can create these types of transitions where we want to have our scene like fade in or fade out, or even have like these screen wipes like this. And so how the pipeline works is in your Phaser scene, you need to tell your pipeline manager about this pipeline. So we need to tell the game configuration like, hey, we have this custom pipeline we want to use. And one way to do that is we can reference our pipeline manager and call the add post pipeline method to do that. Finally, we then need to tell our game object or our camera, in this case, that we want to use that pipeline. And so when we do that, now when Phaser renders out our game, for every tick or update in our scene, we're going to go ahead and apply that pipeline to our game object. And where things get interesting is on your pipelines, there is this onPre-render method that will be invoked for every update in your game loop. And this allows you to set custom variables and then pass that to your pipeline so you can do something with it. And so as an example, what we're going to build is we're going to work on this wipe shader where basically we wipe from left to right. And based on a custom variable we set, we're going to set a variable, and depending on that variable, that's how far we're going to wipe or turn our screen black to create this nice transition here where we wipe our screen from left to right. All right, so now we went over some of the basics. What we're going to do is we're going to start building out our first shader, and we're going to do our wipe postfx pipeline. And so one of the key things we're going to need for each of our pipelines is we're going to use that custom variable that we pointed out over in the abstract class here. So when we pass in a variable, we need to define that in our shader like this, and then down in our shader main function, we can reference it and do something with it. All right, and so for our shader, what we're going to want to do is we're going to want to pass a variable that's going to have a value between 0 and 1. And so when we pass that variable, we're going to use that for comparing our screen's coordinates to determine if we need to render out that pixel as black or not. And so how our shader works is for each of our pixels that appear on our screen, our shader code is going to run for each of those individual pixels. And so when our shader program runs, we're going to have the coordinate of that pixel, and that's what this out text coordinate is here. It's going to give us our X and Y value of what pixel we're looking at. And then so based on that data, we can do something with it. And so to create this effect, it's actually pretty simple. What we want to do is we want some value that's going to be passed, like here it's going to be 0.5, and we're going to want to look at that value. And from that value, we're going to want to look at our X position on our screen to know if a pixel should be rendered black or should be rendered the color of the original texture. And so to do that, when our shader runs, our coordinate for our pixel is going to be a value between 0 and 1. And basically for our X value, our 0 is going to be the left-hand side of our screen, and our right side of our screen is going to be 1. So depending on that value, it's going to be between 0 and 1. And so for our Y value, it starts at 1 at the top and goes down to 0 at the bottom. And so for our coordinate, our X value between 0 and 1, and our Y value from 0 to 1 as well. And so to create this effect, all we need to do is we need to take that pixel's coordinates and compare it to this value here. And if it's less than or equal to it, then we want that pixel to be black. Or if it's greater than, we want to go ahead and render out the original color. And so to go ahead and do this, we can just do a simple if statement. So we're going to do if, and we're going to look at our out text coordinate, and specifically we want our X value. And so if it's less than our custom variable here that we're receiving, so our U cut off, then we want to go ahead and set our color. And so our GL frag color here, we want to go ahead and set it to the color black. And so to do that, we can just do a new vector 4, and we'll do 0, 0, 0, and we'll do 1 for the alpha. And so this is going to be our RGB, so red, green, blue, and then our alpha for our vector 4. Otherwise, we can do our else block, and inside here, we're going to just run our original code that we had set. Let's go ahead and save our changes. Now, if we come to our shader, what we should see now is as we update our progress value, we can see that our shader is being applied to our camera, and our effect is working how we expect it to. And so we hit play transition, we should now have this nice effect where we start from the left-hand side of our screen and we wipe to the right. So for our next shader, what we're going to do is we're going to work on this curtain rise effect here. And so basically what we want to go ahead and do is, it's going to be very similar to what we did before, where we're just going to take the position of our coordinate that we have for our pixel, so our Y value this time, and we're going to compare it to our value. And if it's less than it, we'll go ahead and do it black. Otherwise, we'll go ahead and render out the original color. And so one thing to note is because the top of our screen is set to 1, we are going to go ahead and set our initial value for our progress to be 1 for our cutoff variable. Otherwise, what would happen is when we add our shader to our camera or our game objects, it gets applied immediately and it'll start being rendered out to our scene. And so if we have our progress set at 0, because the bottom of our screen is 0, that would have the effect of our whole scene being black. Let's go ahead and create this transition. What I'm going to do is I'm going to come back to our wipe postfx class. I'm going to go ahead and copy our code. I'm going to go ahead and paste it. And then all I'm going to go ahead and do is I'm going to go ahead and change this to Y. And we want to go ahead and do, if it is greater than our cutoff, then we want to go ahead and apply our effect. So if we come back to our scene, if we go ahead and do our curtain rise, now if we go ahead and adjust our slider, we'll see now when our value is greater than the value provided, we go black. Otherwise, we go ahead and have our original color. So the next two shaders we're going to take a look at is going to be this opening bars here, where we have these bars start from the center of our screen, and they go ahead and expand to the top and bottom until we can see our whole screen. And we're going to look at this closing bars where it does the inverse, where we have two bars start at the top and bottom, and they slowly come to the center of our screen. And so for these shaders, we're going to have to do something a little more interesting to calculate if a pixel should be rendered as black or the original color. And so what we're going to want to do is if this box here represents our canvas and our coordinates that are available to us are 0 to 1 for our x value and 1 to 0 for our y value, then we know our center is always going to be 0.5 for both the x and y. And so for our shader, we're going to want our progress value or our cutoff to represent how much of our screen we want to render as black. And so to do this, we want to go ahead and cut our canvas, our screen, into halves. And the reason for that is when we look at our values here, what we're saying is our progress is our overall percentage of our screen we want to go ahead and color black. And so when it's at 0.2, what we're saying is out of our total screen, we want 0.2 of it to be colored black. But for our halves, we're saying 0.1, so 10% in the top and 10% of the bottom, because we want to go ahead and mirror whatever we do on the top to the bottom as well. And so what that results in is basically whatever our progress value is, we're going to go ahead and cut that in half and apply that to both our top and our bottom halves to get that amount we're looking for. All right, so to figure out what portions we actually need to go ahead and color black, we need to figure out how to take our overall y coordinate and see if it falls in the area we're looking to shade. So as an example, if we want to shade 50% of our screen, what that really means is that we need to shade the top half of our screen. We want to do 1/2 of that half or 1/4 of our screen. Likewise, we want to do the same thing to our bottom, and so we're only going to go ahead and color 1/4 of our total screen or half of our half. And so in terms of our global coordinates, so remember, for our y value, go from 1 down to 0. So if we get a y value that is at 0.9, we would know to go ahead and color it in because when we take our half, we're really going from 1 to 0.75, and if our y value is within that range, we color it black. And so our 0.9 would fall within that range, versus if we had like 0.4, that's going to go ahead and be below our range, and so it'd actually be the original color. Likewise, we're going to color from 0 to 0.25, and so if we get 0.15, we would color that in, versus if it was 0.45, we'd do the original color. All right, so go ahead and start writing our code. What we'll do is we're going to start with our closing bars post-fx pipeline. And so for this shader, what we want to go ahead and do is, so for our math equation, basically first we need to take our difference, our cutoff, we need to go ahead and cut that into half. So that way we can use that for our top and bottom halves. So to do that, we'll make a new float. And so we'll do float. We're just going to call this diff. We're going to set it equal to our cutoff variable. And we'll go ahead and divide it by 2.0 for our float. And now what we need to do is with that diff, we need to go ahead and, for knowing which area to shade in, we need to start at 1. And we'll go ahead and subtract that difference, and then that's going to be our area to go ahead and shade in. And so what we'll do is we'll just do an if statement, and so we're going to take our coordinate, so our out text coordinate, we want to grab our y value, and we'll compare that. And so if it's greater than or equal to our... And so we'll go ahead and compare that to the top of our screen. So we'll do 1.0, and we'll go ahead and subtract our diff that we just calculated. And if our value is greater than this value here, it'll be within this range. So what we'll want to do is color that black. So let me go ahead and copy this here. We'll go ahead and paste it. And then what we should be able to do is test our changes. So if we come over to our browser, let's go ahead and go to our closing bars. And so we go ahead and try tests. Oh, yep, so we actually need to fix this. This needs to be an else block, so then that way we're not overwriting our color every single time. So now if we go ahead and save, let's go ahead and test our shader again. So we'll do closing bars. If we update our progress, we'll see now we have our bar starts at the top and it comes all the way to the center, just like we expect. So now to go ahead and do the bottom bar, basically what we just need to do is we need to do the same thing for our if check, but then take our 0 value and add the difference we need to go ahead and compare. All right, so what I'm going to go ahead and do is I'm just going to go ahead and group this together, and we'll go ahead and do an OR, And we want to go ahead and do another comparison. So I'm just going to copy this. We'll go ahead and paste it. But now we want to know if it's less than or equal to our 0, so the very bottom of our screen. And instead of taking the difference, we want to go ahead and add it. So now if we go ahead and save, we should go ahead and test our full effect. So if we do our closing bars, nice. All right, so for our next shader, our opening bars, what I'm going to do is I'm going to copy our code from our closing bars, and we'll go ahead and bring it over. And so this shader is very similar to our other one. However, when we go to calculate which area we need to shade, we actually need to start from the center of our screen. And so basically all we're doing is we're starting at the center of our screen, and then we're going to take our progress and cut it in half, and then either add or subtract that value to find out which area should be visible to the player. And so go ahead and do this. Let's jump over to our code. And so first what we'll do is let's go ahead and change our value here. So instead of starting at the top, we're going to go ahead and start at our middle. And so we'll subtract our difference. And so when we subtract our difference, we want to know if our y value is less than or equal to 0.5 minus our difference, because it's going to put us down here in the black. And then over here, we want to go ahead and start at our center and add our diff. And now if it's greater than or equal to that value, then we would go ahead and color that black. And so as an example, if our y's coordinate was 0.9 and our progress will go with our 0.5 again, we would want it to be colored black because it's up in this area here. Likewise, if our value was 0.15, we color it black. All right, so we're going to save our changes. We should go ahead and test. Let's come over to our browser. Let's go ahead and change to our closing bar shader. And so what we'll do is if we go ahead and slide our progress bar, we'll see here our bars start at the top and the bottom of our screens, and they slowly move towards the center of our screen. All right, so our last two shaders we're going to take a look at is the first one's going to be this fade to white shader here, where we take our texture, and we're going to go ahead and slowly have it fade out to the color white. And then likewise, our fade to black, we're going to do the same thing, just to the color black. All right, so to go ahead and create these two shaders, what we're going to do is we're going to make use of the built-in mix function. And what that function does is it will literally interpolate between two values for our two colors that we provide. So our original texture color and our target color, white or black. For our progress, that's going to be this linear line here. And so the higher value of our linear line will result in a more mixture of our two colors. And so as an example, if we pretend that this side over here, this blue, is our original texture, then if we provide a progress value of 0, we're going to render out that original color. If we provide a value of 1, then we're going to go ahead and render out the color that we provided, white or black. Versus if it's 0.5, it's going to be somewhere in the middle between these two, where these two colors are mixed together. And so that's all the mix function does, is it just takes our original color and then slowly combines it with our other one, depending on how much of a progress we provide to it, a percentage to use. And so to go ahead and use this function, all we need to do is we need to go ahead and call mix with our original texture color, our color that we want to target, and then our percentage value, which will be our cutoff variable that we're using. So to go ahead and do this, let's jump over to our fade to white postfx pipeline. And the first thing we're going to do is I'm going to make a new variable, and this is going to be for our vector4 for our color white. And so what I'm going to do is I'm going to do vector4. We're just going to call this white. We're going to set it equal to a vector4. And then for our values, so white is all ones. So we'll do 1.0, 1.0, 1.0. And then for our alpha, we'll have 1 as well. And then what we'll do is now we need to go ahead and store a copy of our existing color. And so we'll just make a new variable, we'll do a vector4, and we're just going to do color. We're going to set it equal to this code here. So then that way we grab our color from our texture. And now for our fragment color that we want to output, we're going to go ahead and use our mix function. We're going to provide our original color from our texture. We want to mix it with our color white. And then we'll go ahead and use our cutoff variable, so then that way we can control how much these two mix together. All right, so if we jump back to our browser, we should go ahead and test. Let's go ahead and switch to our fade to white shader. And so when our progress is 0, we're doing our original color of our texture. And as we slowly move up our progress, we'll see our two colors mix together more to eventually get to our color white. And so if we go ahead and play our transition, you'll see we get this nice fade to white effect. All right, so for our fade to black, it's going to be very similar. So what I'm going to do is I'm going to copy this code here. I'm going to jump over to fade to black. I'm going to go ahead and replace our main function. Then I'm just going to update our variable name. So it's going to be black. And so as we saw, our color black is just all zeros, and we'll keep 1 for our alpha. And then what we'll do is we'll go ahead and save. Oh, actually we need to update our variable. Let's go ahead and save. And now in our browser, if we go ahead and switch to our fade to black shader, if we go ahead and move our progress bar, we'll see eventually we get to our color black. If we go ahead and play our transition, we have this nice fade effect. All right, with that, that brings this video to an end. And so we saw by utilizing WebGL and the built-in shader support of Phaser 3, we can easily recreate some of the cool battle scene transitions from the classic Pokemon games. And with the built-in custom pipelines and a little bit of code, we can easily create some really powerful fragment shaders in our games. So as a reminder, there is a link in the description of this video to the source code for this video. And as always, thank you so much for watching. I hope you enjoy the content. If you did enjoy the video, please consider liking the video and hitting the bell icon to be notified when the next video is released. For more great Phaser 3 content, please see the links on your screen now.